Okay, good morning. Welcome to
MinuteMath number 174.
MinuteMath number 174. This is not actually the problem from the Mathematical Association of America's MinuteMath blog today, but it is a problem from an old AMCA. They really gave you a hard time today, so I want to spend a lot of time on this. So the question actually, fortunately, is easy to state. What fraction of this square region is shaded? The stripes have equal width and the figure is drawn to scale. So, that's the question, and they have this picture that we've actually recreated with a ruler. Okay? So, tell me a little bit about how you'd like to start on this.
Well, we can make a chart.
Okay, a chart, okay.
So I'm going to call this row 1.
All right.
This one 2, 3, 4, 5, and 6.
Okay.
So we have row number, and then I'll say whites and blacks.
Okay, great.
So in row number 1, we have no whites and 6 blacks.
Okay, how did you, in this all the way up to the top?
Yeah.
Okay.
This.
How did you count 6 up there?
Well, since you can count, this is 1 unit.
Yeah?
Then there's another 1, 2, 3, 4, 5, and 6.
Oh, okay, awesome.
So
6 blacks in this row, okay?
I'm just gonna write the rows down to save some time.
Okay, super.
So row 2, we have 5 whites and 1 black.
Okay.
3, we have 5 whites. 5 blacks and 1 white. Oops.
Let's erase. Okay, you gotta be careful when you're making your chart. Okay.
5 blacks and 1 white.
All right, that's row 3. What about row 4?
Row 4 has 3 whites. Wait, 4 whites.
Okay.
And 2 blacks.
All right.
Row 5 has 4 blacks and 2 whites. Row 5, well, I meant to say row 5
Yeah,
over
yeah.
here. So row
Row
6 has 3 and 3.
Okay.
So they want what fraction of the square region is shaded. So you have to add up this. Let's do that here.
Okay.
So 0 plus 5 plus 1 plus 4 plus 2 plus 3. So this is, 5 plus 5. It's 15.
Okay, so there's 15 white.
So do they want the whites on top or the blacks on top?
Well, it says what fraction of this square region is shaded?
So the whites are on the bottom. Wait a minute. So what fraction is it shaded? Actually, it's out of 30. We don't really need the whites though.
You don't even need to count the whites.
So it's 36.
Okay.
And then is this 15 also? Let's see. So 7, 12, 14, 18, 21.
Okay. 21 out of 36.
So we can cancel a 3 here.
Okay.
And we get 7 twelfths.
Very good.
Which
Which
is
is a
C.
choice. Okay, now, a couple other things. There's another pattern you could have counted rather than counting the rows. Do you see any other patterns in this picture?
Well, it goes, the whites are always odd numbers.
Okay.
It's good. Actually, all of them are odd numbers.
Yeah.
There's 1, 3, 5, 7.
1, 3, 5, 7, 9, 11 in each L,
Shape.
right? So to count the blacks, it's 10 plus 11, which is 21 out of 36. The other thing I wanted to point out, just looking at the picture, can you tell, are there more blacks or whites without adding them up?
Well, it kind of looks like there's more blacks than whites.
Kind of does. We can group them in the two L's together. You see there's more blacks in this bit. And what about this L and that L?
There's more blacks when you group the squares together.
Yeah, and there's more blacks. So right away we could know that this is not a choice and this is not a choice. So at least we could narrow it down to 3. Okay, good job. Find a pattern, count them up. That's a great way to approach this problem. Find a pattern, count them up.